Hey you guys, this is Mr. Millings, and in this video we are going to learn how to find the mass of excess reactant in a chemical reaction. So let's take a look at this problem here. In this problem, it says 50.0 grams of aluminum sulfite reacts with 60.0 grams of sodium hydroxide according to the reaction equation shown below. We need to determine the limiting reactant, calculate the mass of aluminum hydroxide that is produced, and last, we need to determine the mass of excess reactant. So we're asked to do three things here. We have a chemical reaction right here, in which 50.0 grams of aluminum sulfite is reacting with 60.0 grams of sodium hydroxide. We need to figure out, number one, which of these two reactants is going to run out first in the chemical reaction, which of these reactants is the limiting reactant, in other words. Secondly, we need to figure out how many grams of aluminum hydroxide will be produced. And third and finally, we need to determine the mass of the excess reactant. So, how do we do this? Well, let's go ahead and take a look at what's happening here. The very first thing we're going to have to do is balance our chemical equation. So let's go ahead and balance the chemical equation. Our chemical equation is now balanced. And so, if we read this question, we have 50.0 grams of aluminum sulfite reacting with 60.0 grams of sodium hydroxide, and we need to figure out, as it says in the question, the mass of aluminum hydroxide that will be produced. So, in step number one, what we're going to do is we're going to find the limiting reactant, and we're going to find the mass of aluminum hydroxide that will be produced. Once we're done with this step, what we can then do in step two here is we can use the initial amount of the limiting reactant to determine the mass of the excess reactant that was consumed during the chemical reaction. So in step two here, what we're going to do is we are going to find the mass of excess reactant that was consumed during the chemical reaction. So that's what we're going to do in step two. Once we figure out the mass of the excess reactant that was consumed, in our third and final step, we can then subtract that amount from the initial amount of the excess reactant to figure out the mass of the excess reactant that is left over. So in the third and final step, we're going to find the mass of the excess reactant that is left over once the limiting reactant runs out during the chemical reaction. All right, so let's go ahead and start with this very first step. In this very first step here, we have 50 grams of aluminum sulfite reacting with 60.0 grams of sodium hydroxide. We need to figure out first how much aluminum hydroxide will be produced and which of these two reactants is going to run out first. Which of these two reactants, in other words, is the limiting reactant and limits the amount of aluminum hydroxide that will be produced. So what we have to do is we have to set up two problems. We're starting with 50 grams, 50.0 grams of aluminum sulfite, and we're also starting with 60.0 grams of sodium hydroxide. So what we have to do is we have to run the stoichiometry process twice. We need to figure out how much aluminum hydroxide will be produced from 50.0 grams of aluminum sulfite, and then we need to figure out how much aluminum hydroxide will be produced from 60.0 grams of sodium hydroxide. So we're assuming that since you're watching this video, you already are familiar with how to find molar masses and mole ratios and all that good stuff. So if we take a look right here, we're starting with 50.0 grams of aluminum sulfite. We know that 1 mole of aluminum sulfite is 294.17 grams of aluminum sulfite. And if you're wondering where we got this number from right here, this is the molar mass of aluminum sulfite. This is the molar mass of 2 aluminums, 3 sulfurs, and 9 oxygens all added together, and that's where we get this using our periodic table. So now we have grams of aluminum sulfite that cancel out, leaving us with moles of aluminum sulfite. So what we have to do in our next step is our mole ratio. We want to cancel out moles of aluminum sulfite, so we're going to put that at the bottom here. And we want to figure out how many moles of aluminum hydroxide. So if we take a look at our mole ratio here, there's 2 moles of aluminum hydroxide to just 1 mole of aluminum sulfite. So moles of aluminum sulfite now cancel, leaving us with moles of aluminum hydroxide. Well, now we need to cancel out moles of aluminum hydroxide. And we need to figure out how many grams of aluminum hydroxide there are, since that's what the question is asking for. So we know 1 mole of aluminum hydroxide is 78.01 grams. That's the molar mass of aluminum hydroxide. Moles of aluminum hydroxide now cancel, leaving us with grams of aluminum hydroxide, and that's what we're trying to find. We're trying to find the mass of aluminum hydroxide. So now we get our calculator out, take 50.0 divided by 294.17 times 2 times 78.01, and we end up with 26.5 grams of aluminum hydroxide. So this isn't our final answer. We now need to figure out how many grams of aluminum hydroxide can be produced from 60 grams of sodium hydroxide. So let's go ahead and do that. We know that we need to cancel out grams of sodium hydroxide, so we'll put that at the bottom here. And we're going to convert to moles of sodium hydroxide. So we'll put that at the top. And we know that 1 mole of sodium hydroxide is 40.0 grams of sodium hydroxide from our periodic table. 1 sodium, the molar mass of 1 sodium, 1 oxygen, and 1 hydrogen is 40 grams, 40.0 grams. So now if we take a look, our mole ratio here is 2 moles of aluminum hydroxide to 6 moles of sodium hydroxide. 6 moles of sodium hydroxide, right? That will allow us to cancel out moles of sodium hydroxide now, leaving us with moles of aluminum hydroxide. So now we're going to have to cancel out moles of aluminum hydroxide, so we're going to put that at the bottom. And we're going to have to convert to grams, or figure out the number of grams of aluminum hydroxide, so we'll put that at the top. And once again, we know 1 mole of aluminum hydroxide is 78.01 grams. 78.01 grams. So let's go ahead and put this in our calculator. 60.0 divided by 40.0 times 2 divided by 6 times 78.01, and we'll end up with 39.0 grams of aluminum hydroxide. As we see here, moles of aluminum hydroxide on top and bottom cancel. Moles of sodium hydroxide on top and bottom cancel. Grams of sodium hydroxide on top and bottom cancel, leaving us with grams of aluminum hydroxide. So in the first two questions, it says determine the limiting reactant and to calculate the mass of aluminum hydroxide. So how much aluminum hydroxide can be produced if we have 50.0 grams of aluminum sulfite and 60.0 grams of sodium hydroxide reacting? Is it this much right here, or is it this much right here? Well, we go with the lesser of the two values. So this much aluminum hydroxide will be produced. 26.5 grams of aluminum hydroxide will be produced because when the 50.0 grams of aluminum sulfite run out, you can't make any more than this much aluminum hydroxide. So this much can't be made because the aluminum sulfite is going to run out. So which of the two reactants here is the limiting reactant? The limiting reactant here is our aluminum sulfite. So Al2 SO33 is the limiting reactant. So we just got done answering the first two parts of this question right here. The limiting reactant is our aluminum sulfite, and 26.5 grams of aluminum hydroxide will be produced, no more than that. So in the second part here, it says to find the mass of the excess that was consumed. So if this is the limiting reactant right here, then that's going to make this stuff the excess reactant. And what we need to do is find the mass of the excess reactant that was consumed. So we have to find the mass of the sodium hydroxide here that was consumed based on the initial quantity of our limiting reactant. So our initial quantity of the limiting reactant was 50.0 grams of aluminum sulfite. And what we're going to try to do is figure out how much sodium hydroxide was consumed. So if we take a look, first thing we have to do is convert the grams of aluminum sulfite to moles. And we know that 1 mole of aluminum sulfite is 294.17 grams. That's the molar mass of aluminum sulfite. Next, our mole ratio now, we're comparing the excess reactant to the limiting reactant. And if we take a look here, there's 6 moles of NaOH to 1 mole of aluminum sulfite. And so we can see now what's happening is that moles of aluminum sulfite on bottom here will cancel out with moles of aluminum sulfite on top. So that's going to leave us with moles of sodium hydroxide. Well, we need to figure out the mass. We're trying to figure out the mass that was consumed of sodium hydroxide. So we got to carry this a step further. We know that 1 mole of sodium hydroxide is 40.0 grams of sodium hydroxide. And so if we take a look, grams of aluminum sulfite on top and bottom are going to cancel out. Moles of aluminum sulfite on top and bottom are going to cancel out. Moles of sodium hydroxide on top and bottom are going to cancel out. And that's going to leave us with the grams of sodium hydroxide that was consumed, or the grams of the excess reactant that was consumed during this chemical reaction. So now we take 50.0, we divide that by 294.17, we multiply by 6, and then we multiply by 40.0, and we're going to end up with 40.8 grams of sodium hydroxide that was consumed. So we know that there was 40.8 grams of sodium hydroxide that was consumed, but we started with 60.0 grams of sodium hydroxide. So how do we find the mass of the excess reactant that's left over? Well, if we started with this much sodium hydroxide, and we know that this is the excess reactant, and we're left with this much sodium hydroxide, well, all we need to do is subtract this amount from the initial amount, and that will give us the mass of the excess reactant that's left over. So if we take the initial amount of our excess reactant, which is 60.0 grams, let me rewrite that. We have 60.0 grams of NaOH, and we subtract the amount of excess reactant that was consumed, which is 40.8, this will give us the amount of excess reactant or sodium hydroxide that is left over. And we're going to end up with 19.8 grams of NaOH left over, or in excess. So in this problem here, we determined the limiting reactant. It's our aluminum sulfite. That's what's going to run out first in this chemical reaction right here, based on these quantities. We then determined that no more than 26.5 grams of aluminum hydroxide can be produced. We then figured out in step 2 the mass of the excess reactant that was consumed. We used the initial quantity of our limiting reactant, which we found in step 1, to determine the mass of the excess reactant that was consumed. The excess reactant is sodium hydroxide. And then last but not least, we subtracted the amount of the excess reactant that was consumed from the initial mass or amount of the excess reactant, and that gave us 19.8 grams of sodium hydroxide in excess or left over. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions down below. And I really hope you guys found this helpful.